Problem 5.3 is about calculating limits at infinity, right? So we have an expression here, and we need to calculate the limit when x goes to plus infinity. But in all these cases, one point that you should address is what is the leading term of the expressions that you have here in the numerator and the denominator. Well, this is a polynomial and it's easy. The leading term is this one, is x cubed, the highest power. So we factor it out, right? That's x cubed. And then you have 1 plus 4 divided by x squared minus 7 divided by x cubed. This way, you can see that this is the only term that is relevant, because in this limit, this is going to go to 0 and this is going to go to 0. So this limit goes to 1. Similarly, in the denominator, what you have here is 7x squared. And then you have this square root here, and we can factor out the leading term down here, which is this one, right? So we factor this x to the 6, right? We take it out, and it comes out of the square root as x cubed. So we have minus x cubed times the square root of 2 plus, and since we are factoring out an x6, this becomes 1 over x. All right. Now again, this x cubed can be factored out, right, globally, and then we have the limit x cubed 1 plus 4 over x squared plus minus 7 divided by x cubed, everything divided by, and now factor out the x cubed, we have 7 divided by x here, minus the square root of 2 plus 1 over x, okay, when x goes to infinity. Now this factor cancels, and all we have to do is calculating this limit. But this is straightforward, because as I said, this goes to 0, this goes to 0, this goes to 0, and so does this. So the limit of the numerator is 1, and the limit of the denominator is minus the square root of 2. So the limit of this expression is minus 1 over the square root 2.